Now 4 variable Kmap. So as you got 4 variable, definitely we can expect 16 combinations. Okay, karnaugh map can be extended to 4 variables. So top cells are adjacent to bottom cells, left cells are adjacent to right edge cells. So these are nothing but top cells and these are nothing but the bottom cells, and all these top cells are adjacent to these bottom cells, and these are nothing but the left cells and these are nothing but the right cells. All these left cells are adjacent to the right cells. Okay, so as you have 4 variables, definitely you will be getting 16 combinations or 16 minterms, as you can see here, and we are following the gray code sequence. So M0, M1, M2, M3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They have represented all those minterms with variables in this way on the right hand side. Okay, so Wx should be on one side and Yz should be on the other side. Okay, one cell represents a minterm of 4 literals. So if I'm going with only one cell, then it is going to represent 4 literals in a 4 variable map. For example, if I'm only grouping this M2, then this particular cell is going to represent 4 literals, that is W, X, Y and Z. Okay, a rectangle of 2 adjacent cells represents a product term of 3 literals. So if I'm grouping 2 adjacent cells, it means if I'm grouping 2 cells, then I'm going to get only 3 literals. A rectangle of 4 cells represents a product term of 2 literals. So if I'm going with a grouping of 4 cells, then I'm going to get only 2 literals. A rectangle of 8 cells represents a product term of 1 literal. So if I'm grouping totally 8 cells, then it becomes, or we'll get the resultant expression as a 1 literal. A rectangle of 16 cells produces a function that is equal to logic 1. Okay, so if you are grouping all these 16 cells, then the resultant expression would be 1. Now simplify the following Boolean function, and these are all the minterms of this particular function. So first we have to put all these minterms on the Kmap. So I have plotted all those minterms on the Kmap, and then you have to form the blocks. Okay, and always we have to go with maximum sized grouping. Okay, so if you can see here, these are adjacent cells. Okay, and we can go with a group size of 8. So I have formed a group whose size is 8. Okay, and then these cells are adjacent cells, therefore I'm making one more block of 4 cells. Okay, and these two are adjacent, therefore I'm making one more block of 2 cells. Okay, and the resultant expression would be this one. Okay, for example, if you consider this particular block of size 8, okay, now here the value of A and B are continuously changing from 0 to 1. So we have to ignore these variables or literals A and B. And if you consider the other variables C and D, that is column variables, okay, you can observe here the value of C is constant, but it is holding 0, so it is represented as bar. Okay, and if you consider the next block whose size is 4, okay, here the value of A is changing from 0 to 1, but whereas the value of B is constant. Okay, but it is holding 0, so that is why it is represented as B bar. And the value of C is changing from 0 to 1, and whereas the value of D is constant, which is nothing but 0, therefore it is represented as D bar. Okay, and the last block that we have is this. Now here the value of A and B are constant, but A is holding 0 and B is holding 1, so that is why A bar B. And whereas the value of C is changing from 0 to 1, therefore it should be ignored, and the value of D is constant, which is nothing but 1, therefore it is written without complement, that is D. So this is what the resultant expression that we have got for this particular function. Need to define some more new terms here, that is implicant, prime implicant and essential prime implicants. Okay, so before going to this, we can also extend these Kmaps for 5 variable as well as for 6 variable, in the same fashion that we have gone with that we have seen with a 4 variable map. Okay, now let us see what are these what about these terminologies, that is implicant, prime implicant, as well as essential prime implicant. Now implicant, any product term in the sum of products form a block of ones in the Kmap. Okay, as we know that all the product terms or minterms are represented with ones, therefore any product term in the SOP expression will be considered as a implicant. Okay, now prime implicant, product term that cannot be further reduced. Okay, so it means a maximum sized implicant is nothing but a prime implicant. So blocks of ones that cannot be further increased. Okay, as I told you that if we cannot able to reduce it further, then that particular implicant is called as a prime implicant. Essential prime implicant, prime implicant that covers a one minterm that is not covered by any other prime implicant. Okay, so if there is any prime implicant that is not covered by some other prime implicants, then that PI is called as essential prime implicant. Let us see these with examples. Okay, so I have plotted this particular function on the right hand side, and I have took this particular Kmap randomly. Okay, now I have gone with groupings of maximum size. So here you can see the maximum size is 4, and here it is 4 again, and again 4, 4. So here in this particular map you can see that essential prime implicants are BD and B bar D bar. Okay, which is nothing but this is BD. Okay, these are called as essential prime implicants because this group is not covered by any other prime implicant. So that is why it is called as a essential prime implicant. Okay, and if you consider this particular map, here the prime implicants are CD, B bar C, AD, and then AB bar. Okay, so what is a prime implicant? Just now we have seen that product term that cannot be further reduced. So the maximum sized grouping minterms are called as a prime implicants. Here you can see that CD is nothing but this term. Okay, and here the maximum size would be 4. We cannot reduce or we cannot increase the grouping size to 8. Okay, and B bar C, which is nothing but this, and then AD, which is nothing but this group whose size is again 4. We cannot increase it to 8, and then AB bar, which is nothing but this whose size is again 4. Okay, let us take one more example. Consider the function f of a comma b comma c comma d whose Kmap is shown at the right side. Okay, so this is what the Kmap where I have plotted all the minterms. Okay, now and I have gone with the groupings, and I have got some blocks here. Okay, and I have got the expressions. So a bar b bar is not a prime implicant because it is contained in b bar. Okay, so a bar b bar, which is nothing but this. Okay, a bar b bar is not a prime implicant. Why? Because we can increase the size of this block, okay, from 4 to 8. Why? Because as I told you that the left side of the map is adjacent to the right side of the map, or else the left side cells are adjacent to the right side cells. Okay, so a bar b bar is not a prime implicant. ACD is not a prime implicant because it is contained in AD. Okay, so here ACD, which is nothing but this red dashed grouping, this is also not a prime implicant. Why? Because we can increase this particular grouping or block into a size of 4. B bar, AD, and A bar, CD bar are prime implicants. So which is nothing but B bar, whose size is 8, as I told you that it cannot further be increased, and then AD, this size is 4, and then A bar, CD bar, and here the size is a maximum is 2. Therefore these implicants are called as these implicants are called as prime implicants. Now what is essential prime implicant? If a minterm of function f is included in only one prime implicant p, then p is an essential prime implicant of f. Okay, as I already told you that if a prime implicant is not covered in any of the prime implicants or implicants, then we can call that particular PI as essential prime implicant. An essential prime implicant must appear in all possible SOP expressions of a function. To find essential prime implicants, generate all prime implicants of a function. So initially we have to generate all the prime implicants. Select those prime implicants that contain at least one that is not covered by any other prime implicant. Okay, if you can see here, okay, now here these are the prime implicants, and these prime implicants are not going to be covered in the other prime implicants. Therefore, all these three prime implicants are called as the essential prime implicants. In the next session, we'll discuss about product of sums as well as sum of product simplifications. Thank you.